Good morning, and welcome to our little sidebar here. What we're going to do, just kind of briefly, is go over the process converting binary numbers to decimal and decimal numbers back to binary. Now, the book says that you can use calculators or online apps for this process, uh, and that's true for this class. You can use a calculator. I will not ask you to do this in class. However, if you're going to sit for the certification exam, for the CompTIA exam, you will not have access to a calculator. You will not have access to online. And so I'm going to run through the process with you, and I will show you how to convert back and forth from binary, to base 10 and back so that you'll be familiar with the process, and I'll give you a few problems to practice on. Once again, this will not be for class per se, except that if you want to do the certification, you will need to know how to do this manually because you will not have access to online tools. You will not have access to your phone or calculator, anything like that during the test. Uh, just a word about industrial certifications. If you're going to be a network engineer, if you're going to be a cybersecurity engineer, if you're going to be anything like that, number one, you need the certifications because that is how the industry measures your performance. Whether that's good or bad, that's not up to me. What matters to me is that I do everything that I can to give you a leg up on being prepared. And so that's what we're doing. So, with that said, let's go ahead and go to the desktop and we're going to look at converting from base 2 to base 10 and back. All right, so here we are. Uh, we're going to see if we can't figure out how to do some number conversions. We're going to start with a base 10 number, and we're going to do a little bit of simple arithmetic review. You probably learned how to do this in third grade, second grade, somewhere in there. Let's say we have a number here, and this number in this case is the number 132. If we analyze this number, we can see that in the 100s place, there's the number digit 1. In the tens place, there's the number 3, and in the ones place, there's the number 2. And in fact, if we break this number down like this, we can say 1 times 100, that's the hundreds place, plus 3 times 10, that's the tens place, plus 2 times 1, that's the ones place. We add those together, and we get the number 132. That is a legitimate way to analyze this base 10 number. That's very simple. Like I said, you probably learned how to do this in second or third grade, and it's pretty straightforward as far as the math goes. You're just basic multiplication and then adding the results of each of these multiplications. So we multiply the place times the digit. We multiply the place times the digit. We multiply the place times the digit. We add them together, and we get the total. So now let's look at the places for base 10. So what I have here is out to 10,000. I have the places. So we have the ones place, the tens place, the hundreds place. Out here would be the thousands place. Out here would be the 10,000s, the 100,000s, the millions, and so on. Each one of these is a multiple of 10, and each one is 10 times larger than the others. So we start off with 1 times 10 is 10, times 10 is 100, times 10 is 1,000, times 10 is 10,000, and so on. Those are the decimal places in the base 10 system. Those are what each of the columns of the numbers stand for. And then the value of those numbers is whatever the number of places times the whatever digits are in those places. And so that's how base 10 works essentially. In base 10, we have essentially 10 digits, 0 through 9. And so when we count 1, 2, 3, 4, 5, 6, 7, 8, 9, we get to 9, then we start over again. We add a place, 10, 11, 12, 13, 14, 15. We use up our digits until we get to 99, and then we have to add a place. And we start over again, 1, 2, 103, 104, until we get to 999, and we have to add a place. Now we're at 1,000. And same 10,000, 100,000, million, and so on. So essentially what you're doing is you're using 10 numbers to fill up each of these places. In base 10, you can have up to 10 numbers. This number could be 1 up to 9. This number could be from 1 to 9. This number could be from 1 to 9. You would multiply whatever digit that is times the place, add them all together, and that would give you the number. If there are questions about that, let me know in the comments, or send me an inbox message. All right, so that's base 10 essentially. Now let's go ahead and look at the binary system, which is exactly the same process, only you have fewer digits to work with. First of all, the places. These are the binary decimal places. 1, 2, 4, 8. This is like 1, 10, 100,000. Only in binary, you only have 2 digits to work with. That is a problem. You have 0 and 1. You'll notice that each of these places is a multiple of the number 2, which is how many digits you have to work with. That's the base of the system, is 2. So what you have here is 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, 128. We could go to 156, 1,024, 2,048, and so on, but we don't need to. Like I said a while ago, in IPv4 networking, the biggest number you'll ever have to deal with is 255, so we don't need the 256th place out here. We work the numbers the exact same way. So let's say we have the number 110. Now, this is not 110. This is a binary number, so we just say the digits, 110. You will find me making that mistake about 1,000,000 times every class period, but that's okay. Ideally, you should not say this is 110. This is the number 110 in binary. So we have places, and they correspond to these places up here, just like we did in the base 10 system. And we add and multiply, just like we did in the base 10 system, in order to convert these numbers to base 10. So the number 110, we're going to put the digits in with their bases. We're going to add them and multiply. So we've got 3 places here. We'll start with the 3rd place here. That's the 4th place. And we're going to have 1 times 4. The next number's a 1 in the 2's place. 1 times 2. And the final number is a 0 in the 1's place. I'm going to say 0 times 1 because 0 times 1 is essentially 0. Anytime you have a 0 here, it doesn't change the value of the number at all. But it does take up a place. All right, so we're going to multiply. 1 times 4 is 4. 1 times 2 is 2. 0 times 1 is 0. We're going to add them together. 4 plus 2 is 6, plus 0 is still 6. And that tells us that the number 110 in binary corresponds with the number 6 in the decimal or base 10 system. If you want to prove that, then count up to 6 in binary, remembering that you can only add zeros and ones before you have to switch to the next place. So that would be 0, 1, 1, 0, 1, 1, 100, 1, 0, 1, 1, 1, 0. So the number 6, the 6th number in the binary system is 110. If that makes better sense. Just like the 6th number in the base 10 system is 6, the 6th number in the binary system is 110. And essentially, it's exactly the same process. We have the places, we have the digits, we put them in the corresponding columns, we multiply and add, and that is how we convert from a binary number to a base 10 number. So let's go ahead and do another one. We're gonna pick a different number just for practice, and we're gonna say this number is gonna be 111. Okay, so the number 111, that is a binary number, and we're gonna convert it to a base 10 number. And the way we do that is we're gonna put it into the places, and we're going to multiply just like we did. So we're going to start out here. This will be in the 4's place. We have 1 times 4. And I'm going to put parentheses in here because it's the right thing to do. Plus 1 times 2 plus 1 times 1. We can multiply that out. 1 times 4 is 4, 1 times 2 is 2, 1 times 1 is 1. So we have 4 plus 2 plus 1, and that is in fact 7. So the number 111 is the number in binary is the number 7 in base 10. That would make sense because a while ago we discovered that 110 was the number 6. Essentially we added 1 to 110 to make it 111. That makes this number 7. You can do the same process if you want to count up to 7. You have 1, you have 10, you have 11, you have 100, you have 101, you have 110, you have 111. That's the 7th number. And so that is how you convert. You put the digits in their corresponding columns, you multiply, and you add. And that's pretty straightforward. Let's do one more and make this one a little bit bigger. And we're going to go 11011. How about that? Okay, so what we have to do is exactly the same thing. We're going to put the digits into their corresponding columns, and then we're going to add, multiply and add. So let's start off. That's going to be the 5th. 1, 2, 3, 4, 5. 3, 4, 5. So we're going to start in the 16th place. So we have 1 times 16 plus 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. So we multiply and add. 16 times 1 is 16. 8 times 1 is 8. 0 times 4 is 0. 1 times 2 is 2. And 1 times 1 is 1. So we have 16 plus 8 is 24, plus 0 is still 24, plus 2 is 26, plus 1 is 27. And in fact, the number 11011 in binary corresponds to the number 27 in decimal. And that is essentially how we convert from binary to decimal place numbers. You take the digits that are in the binary rows, you put them with their corresponding place number, just like we did with the base 10 numbers. You multiply each one, and then you add them together. The total that you get when you add them together will be the number that this number represents in base 10. So if there aren't any questions, like I say, if there are questions, go ahead and hit me up with a Canvas inbox message or an email if you have questions. If not, I'm going to start the next video and we will look at changing from base 10 to binary. So I'll see you in the next video.